Hello everyone, welcome to Roots of Unity. My name is Marzukh, and in this video, we're continuing functions. Today, we're going to explore another type of function known as the composite function. So what are composite functions? They're basically one way of writing a function inside another function, whereby one function sort of depends on the other. So if this is f of x and this is g of x, we could connect the two functions by writing g of f of x. So inside of g of x, instead of the x, we put the f of x here. Thus, as a result, g of f of x is produced. Note that in g of f of x, the f of x function is first processed and then the g of x function is processed. So sequentially, first the inside function and then the outer function. The output of f of x, let me just use this color. The output of f of x becomes a part of the input of g of x. So for g of f of x to exist, the range of f of x has to be contained within the domain of g of x. Let's see an example to clear the concept more. Alright. Given that f of x is equal to 2x plus 3 for the domain x is greater than or equals to minus 10, and g of x equals to x squared for the domain x is greater than or equals to 0. Find g of f of x and its domain. Hence, find g of f of 5. Alright. So let's find out the expression for the g of f of x. Okay, we write g of x, which is x squared, right? And we know that how we write g of f of x is basically inside of the x in the g of x, we just plug in the f of x. So instead of the x, we substitute the 2x plus 3. Thus, g of f of x is actually 2x plus 3 whole square. That's it. That's how we find out the expression for g of f of x. Now, to find out the domain for g of f of x, we gotta first see how much of the range of f of x is contained within the domain of g of x. This is necessary because it may not always be the case the entire range of the f of x function lies within the domain of g of x. So let's see this number line. Okay, so we can see that the domain of g of x, and we can also see the domain of f of x. Let's now display the range of f of x, which if we calculate it, we'll find out that it's greater than or equals to minus 17. As in minus 17 is the negative minimum value. All right, let's use the orange color for this to show the range of f of x. Okay. Now you can see that a part of the f of x range values does not lie in the domain of the g of x. This is the values between minus 17 to 0. These values for f of x, for the range of f of x, do not lie in the domain of g of x. These values do not exist in g of x's domain. So putting these values in the g of f of x would be violating the domain of the g of x. Hence, to make sure that we do not violate the domain of g of x, we have to select g of x's domain for g of f of x's domain. Sure, this does ignore some values from the domain of f of x, but at least that would not violate the domain of g of x. Think of this as restricting the domain of f of x indirectly, but we don't think about the domain of f of x here. Rather, the range of f of x and the domain of g of x. Hence, the domain of g of f of x is also x greater than 0. X greater than or equals 0, which is the same as g of x domain. But think about it. If the domain of f of x was x rather than x greater than or equals to minus 10, let's just erase this part. And instead, if the domain was x is less than 10, then what would have been the domain of g of f of x? Pause and think about it. Well, the answer for this new domain would have been x is greater than 0 and less than 23. Actually, it's x greater than or equals to 0. Now, why is this? Well, for the lower limit, we can see that for the domain of g of x is still greater than or equal to 0, right? So the range of f of x would now be a new value, which is 23, the maximum value of f of x. And instead of this range, it's gonna change now. The new range is, it's gonna go this way, which is less than 23. And now we're finding out the common region of the domain of g of x and the range of f of x. That is actually how we find out the domain of g of f of x, the composite function. It's always the common region of the range of f of x and the domain of g of x, as in the range of the inner function and the domain of the outer function. So the common region here is this part, which is 0 to 23. So x is greater than or equals to 0 and less than 23. So what is g of f of 5? We found out g of f of x with this, right? We can simply plug in the value of 5 here, then we can solve this. Well, if they did not ask you for the expression, and if they directly told you to find g of f of 5, we could have solved this in another way. We could have found out f of 5 first, and whatever the value is, we could have plugged this in g of x. So g of f of 5 would give the same result. Okay, now before I wrap it up, we're going to see a meme, which I created, because who doesn't like memes? Alright, here is my good friend Shomo eating a burger. Below is the g of f of x, where Rex eating Shomo is g of x, and Shomo eating the burger is f of x. Sorry if you thought Rex didn't eat humans, but he makes exceptions for Shomos. So here, this is f of x, and this is the f inverse x, and basically how this works is, wait, why am I explaining this meme? I'm pretty sure you guys have seen these memes, right? Oh, wait, who explains memes? Gee. Alright, anyways, that's all for today. In this video, we have covered composite functions. In the next and final video of this chapter, we're going to cover transformations. My name is Marzukh, and this was Functions. See you later.